Okay, Year 9. This is our last lesson for the topic of right-angled trigonometry. In this lesson, we're going to look at bearings. So far, we've learnt about the trig ratios, sine, cosine, and tangent. We've learnt how to find an unknown side, an unknown angle, and last lesson we learnt about angles of elevation and depression. A bearing is a measure of the direction or position of an object, and we use a compass to measure the bearing. There are two systems that we need to be familiar with. There are compass bearings and there are true bearings. Now, compass bearings you're probably familiar with, but as well as north, east, south, and west, we also need to know northwest, northeast, southeast, and southwest, and in between all of those. So here we've got west, northwest, north, northwest, which we actually say nor-northwest, and here's nor-northeast. A true bearing is the rotation from north in a clockwise direction. So we locate north, we rotate clockwise until we hit the arm that goes out to the object. So we would say in this case the bearing of S from P is 125 degrees true. You can put the T on the end, you can leave it out. This word, however, is really important. The letter that comes after that word from is the letter that goes in the center of the compass. So it says from P, so at the point P we're going to draw the north, east, south, west. Let's look at a couple of examples. Write the bearing of A from O. So here is north. We want to go in a clockwise direction all the way around until we hit that arm. So it's this angle here. Now we know that a complete revolution is 360 degrees. So we want 42 degrees less than a complete revolution. So to find that bearing, we need to do 360 take 42, which is 318 degrees true. Here's another one. So we want from north, clockwise direction until we hit that arm. So it's this angle. Okay, straight angle is 180 degrees. And in this case, I want to do 180 plus 31. So the bearing is 211 degrees true. Here's a harder example. What is the bearing of A from P? Can you tell why this one is more difficult? Have a look at this word, from P. We want the compass to go here. Currently the compass is sitting here at A, and so is the angle. So the first thing we need to do is draw in a new compass at P. Now let's locate the angle that we want. So we want to go from north, clockwise, until we hit that arm. Here's my question to you. How are we going to use this angle here to work out this one? The key is alternate angles. You might remember those as Z angles. Alternate angles are equal on parallel lines, and these lines, these north-south lines, are indeed parallel. So that means that this angle in here is 70 degrees. So let's write that in. Okay, it's easy now. In order to work out that marked angle, this one here, we want to go 360 take away 70. So we've got 360 take away 70, which is 290 degrees true. We can also convert between compass bearings and true bearings. Here's an example. Write the compass bearing of southeast as a true bearing. So here's southeast here. We want the angle from north in a clockwise direction until we hit that arm. So this angle here. All right, we know that that one in there is 90 degrees. We also know that southeast is halfway between south and east. And so that must be 45 degrees. And so we want 90 plus 45, which is 135 degrees true. Many trigonometry questions are going to involve bearings. We're either going to be given the angle as a bearing in the question and then asked to find one of the sides, or we'll have to find the bearing given the distance measurements. Here's our first example. Katie walks due east for 3 kilometers, then turns and walks on a bearing of 210 degrees. All right, we're going to put our compass in. We want to go from north for 210 degrees in a clockwise direction. This is 180, so it's going to be somewhere in here because all the way around to here is 270. It doesn't have to be to scale, just do it roughly. And then she is going to walk until she is due south of her starting point. Now the aim here is to find a triangle, and I can see the beginnings of a triangle there, and there it is. The next thing we have to do is get an angle inside the triangle. We can't use trigonometry with an angle of 210 degrees, not with right-angled trig. So we've got to get into here. All right, this is 90, this is 180, this is 270. So if I do 270, take away 210, I'm going to get the angle inside, which is 60 degrees. How far south is she? So we want to work out this measurement here. So let's put a pronumeral on that side. Okay, we're ready to do the trig. We don't need any of this anymore. Okay, we've got opposite and adjacent, so it's tan. Tan 60 equals opposite over adjacent. So tan 60 equals x over 3. Take the 3 over the other side. X is equal to 3 times tan 60, which is 5.2 kilometers, and you should put the kilometers in as well. Here's our second example. A ship sails on a bearing of 118 degrees from port. So we want our compass to have P at the center. The ship is leaving port, and 118 degrees is sort of down here somewhere. So let's draw that line in, and here's our ship. If it sails for 320 kilometers, so that's that distance there, how far south of the port is it? So I'm going to construct a line here, and that's the distance that we want, and now I have a triangle. Now you could construct a line here and make a triangle down there and work out this one. That would be perfectly fine. There are multiple ways to do this question. Now we need an angle inside that triangle, which is in here. Now remember, up here is 90 degrees. So 118 take away 90 is going to give us 28 degrees. Now I'm ready to do some trig. We have got opposite and hypotenuse, which is soka toa, it's sine. Sine 28 is equal to opposite over hypotenuse. Sine 28 is equal to x over 320. Take our 320 up and over the other side, and x is equal to 320 times sine 28, which is 150.2 kilometers. And last example, Hester goes on a bushwalk and gets lost. She walks 4 kilometers due north, then turns and walks 7 kilometers due west. What is her bearing from her starting position? All right, so from her starting position, so this is going to be the center of the compass. So let's draw that up. We want from north in a clockwise direction until we meet the arm. We need to construct that line first. All right, so the angle from here all the way around here. Now what we're going to have to do in this situation, and in fact in most situations with bearings when you're asked to find the bearing, is you have to find an angle in the triangle first. So I want to find this angle here. I've got a right angle up here, so let's put a pronumeral in there and do the trig on it. I'll just put a right angle in there. There we go. All right, we've got opposite and adjacent. It is tan. Tan theta is equal to opposite over adjacent. You don't need to put the kilometers in, by the way. That's a common mistake. We only need the numbers. All right, how do we get the tan over the other side? We do inverse tan. So theta is equal to inverse tan of 7 over 4. Put it in the calculator, use shift tan, and we get 60 degrees. So that's 60 degrees in there. Now remember, we want this angle here. So it's going to be 360 take away 60. So the bearing is 300 degrees. Okay, you've made it. That's the end of our first trigonometry topic. If you want to continue on with trigonometry, the next stop would be non-right-angled trigonometry.